Hello folks, this is Mr. Turboville and working on section 2 from module 1, characteristics of function graphs. We've already talked about section 1 already, but I thought I'd try to give you a little bit of some hints and helps, review some things. If you're not open in your book with me, that I'm going to strongly suggest you do so, because if you can see this text here, you can kind of make it out, but if you have your book with you, that will make it a little bit easier to follow, because I can only make it so big and show you only so much on the screen at one time. So we're going to do what we can with that. But hopefully what we're going to do is we're going to cover in probably 3 main sections, and then I'm going to do a 4th section on just regression equations, because that's something that's individual that we're going to use throughout the course that is in this section, but it kind of stands on itself by itself as well. And so here we go. Let's get started on our first section here. And so we're first of all talking about this idea of what are some of the attributes of a function and how are they related to the function's graph. So there's lots of vocabulary, real important stuff that we're going to be talking about here. And so our first little example here, our explore, okay? Again, this is on page 17. Okay, we got this just a generic picture, a function, not really goes with the equation, but here is your picture, so we can talk about some things. And it goes, and it says the domain, it goes from 0 to 11. So here we go. Here's the far left 0, and it goes all the way to the right 11. So that's a good reminder of what that's all about. And it says the range is from -1 to +1. So the bottom number is -1. The tallest number is 1. Okay, because that's domain and range. And so that's just general information. Okay, so we're going to hit 3 basic areas: positive, negative, increasing and decreasing, and then maximum and minimum values. So speaking of, before we go any further, I want to make sure we get something really big across to everybody here. The number one big thing that we got to keep straight is very simple. Okay? I'd like for you to write this across the top with me. Whenever we talk about something, they talk about function values. What they're talking about, okay, what they're meaning, and they're meaning the y's. What are the y values? So when they start talking about function values, okay, they start talking about the function and this word value. Okay, what they're talking about is the y values. So like at this point right here, okay, so that's over 2 up 1. Well, the x is, let me go ahead and change that out and write that right there. So this point right here is 2 comma 1. Okay, well, 2 is the part of the domain, 1 is part of the range. But check this out. The function value is the 1, the y value. Okay, so anytime you see this word, like in the first example we have here, the values of the function, say so that's code for, hey, look for the y value, look for the y value. So that's a pretty big deal. Whenever you see those words, that is what you're trying to be picking out. Okay, so let's go ahead and get this thing rolling here for this first example. It says from 1 to 3. What are the values of the function of the interval 1 to 3? Are they positive or negative? So what are they saying? Are the y's between x's 1 and 3 positive or negative? So let's go ahead and just highlight that. So here's the between 1 and 3. Got that highlighted right there. So they're saying on the stuff that's highlighted, the y values, are they positive or are they negative? Well, they're all above the x-axis, so they're all positive. Okay, they're all positive. Let me change colors here, so just keep track. Let's go to green here. So the next one says the values, again, that is code for y. The y's of the function on the interval from 8 to 9. So where's 8 to 9? So that's this section here. Isn't that 8 to 9? Starting at 8, going to 9, right there. Okay, so from 8 to 9 are the y values positive or negative, where all of them are below the x-axis, so they are negative. Okay, so this is called just a state of being. Any one point, any individual point on here, the y value would be negative. So all of those, so on this integral they say all of those are negative. Okay, so but now, so that's one way, that's one attribute we look for, is looking at the y values from one spot to the next spot. Okay, next we're going to move in here to this whole increasing and decreasing idea. Okay, so let me clear this off and let's move off and start looking at this, move it down. Okay, so get where we can still see everything. Okay, if I can make it any bigger and still see what's going on, everything. Yeah, we may have maybe that'll get the job done. We'll see. Alright. Cutting thing off when I do that. Alright, there we go. You can see everything now. So a function value is increasing. So this is not just one spot. This is when you're moving, what are you moving? Are you moving up or are you moving down? It doesn't matter if you're negative or positive. It's just talking about, are you moving up? Are you moving down? Decreasing. Okay, so in this case, the given function, what word's missing that was up here? The word values. So we're not talking about just the y values now, are we? Okay, we are still talking about the y in a sense, but what's happening here? The function. So we're not looking for just the y, we're looking for what's going on. It says is increasing or decreasing from 2 to 4. So let's highlight from 2 to 4. Okay, so from 2 to 4, right? So that's where x equals 2 and that's where x equals 4. So from 2 to 4, well, from 2 to 3 the y values are positive. From 3 to 4 the y values are negative. But what's happening between 2 and 4? They are decreasing the whole time. Whether they're positive or negative, they're going down. So it's a different thing, and you got to watch your grammar, and that kind of gives you the clue which one you're talking about. Are you moving, or are you looking at just one particular spot? A bunch of little individual spots kind of deal. Okay, and then down here, another example they talk about here is it increasing and decreasing from 4 to 6. So from 4 to 6. So let's look at 4 to 6. So from 4 to 5 to 6. So from 4 to 6, it's going uphill. Even though part of it's negative, part of it's positive, all of it's going uphill. So it's all increasing. Okay? So we've got positive, negative, increasing and decreasing. This is movement. This is travel from one x to the next x. What are you traveling? You're traveling uphill or downhill. Okay? The next piece we're going to talk about here, that's listed, is average rate of change. We're going to come back and look at average rate of change just by itself. Okay? But average rate of change is code for slope, and we'll come back to it in just a minute. But right now, I want to talk about increasing and decreasing. I'm sorry, we just did that. Maximum and minimum value. Okay? So these two guys right here, maximum and minimum value. So that word value showed up again. So we're looking for the biggest y and the what? The smallest y. So you just look at the picture and go to the top of it and you get the y value, and go to the bottom of it, get the y value. Seems to make sense. Watch out though. They put a little tricky thing in here and said, well, this only happens when you have turning points. Only happens when you have turning points. Okay? So this is interesting. Let's go back up to the top here. Okay? And let's see what we find out. Okay? So this is a maximum That's a maximum, and this is a maximum. Okay? This is a minimum, and that is a minimum. Why did I not highlight these two pieces? Well, while this is at the same spot as those are as far as the y value, it's not at a turning point. It has to be at a turning point for it to count as a maximum or a minimum. Kind of a silly, weird thing, isn't it? But it is how it works, and so that's just the deal. It has to be at a turning point. A turning point. And since it's talking about the value, what would be the maximum value? Well, that's just 1, right? And then the minimum value, that ends up being -1 on both of these spots, isn't it? So let's go look at the homework that goes with these kind of questions. Let's look at this homework questions. So we got this picture here, and they're asking about decreasing and increasing. Okay, so what I want you to do first here is just take a look at this guy and put it kind of in a box. Put it kind of in a box. And so the top of this, okay, this far right side goes here. Okay, and then it goes, that's the lowest point. That's the far left. Then we come back across the top. So everything in my graph kind of fits in that box, doesn't it? So when we get to the domain, our domain is going to start on the left-hand side, or 0, and our range, and the right-hand side will be the 18 will be the top of the domain, right? So the domain will go from 0 to 18, and then the range is going to start here. Let's see, what is this? That's 1, so that should be 1/4, 1/2, 3/4, 1, or 0.25, 0.5, 0.75, and then 1. Okay, so right here would be the bottom of my range, and then here would be the top of the range, okay, because that's as far up as it goes. But that's not the first thing they're talking about here. The first thing we're talking about is, where is the function decreasing? Where's the function decreasing? Okay, well, it's decreasing starting here and going down and going down. So I'm going to help you out with the actual numbers here. I won't do all of these, but some of them you got to pay attention, because I'll tell you words, but I won't write everything down. So if it's decreasing from what? This spot here, and then up to this spot here. So you can write that as 3 less than or equal to x less than or equal to 13. Okay, or what else? We can say this is square all x's such that 3 is less than or equal to x, which is less than or equal to 13. Or we could say this is 3 to 13, and use these square brackets right here. Okay? Because this is where it's decreasing. Now the next number 2, or part 2 of this question, is asking about where is it increasing. So I'm going to give you some hints, but you're going to have to finish it up for yourself. Okay? So where is it increasing? Well, it's increasing from here to there. So it's increasing from this number to this number. So you would need to write something that looks like one of these 3 right here. Okay? Because it didn't tell you which one. You get to pick. I'd pick this one. This one's easiest. But is that the only section that it's increasing? Well, no. It's also increasing over here. So your answer is going to have 2 pieces to it if you plan on finishing answering that question completely. Okay? Next. Come on down here a little bit. It says the maximum and minimum values. The maximum and minimum values. Well, where do you find maximum and minimum values? Well, they have to be at turning points, right? And values, again, is code for what? What's the word values? Function values are the y values, which we said big time the first. So right here, isn't that right there? Isn't that the spot that's for the max? And so what would be the y value right there? It's not 3. So for the maximum value. And then you go down to the very bottom, this spot right here. Okay, so that's the minimum. So what is the y value right there? Okay, so that's enough hinting for that. So let's jump on here now to the next section here. Now it asks for the domain and range. I've already answered that. What's the domain and range going with? The domain and range, so the domain starts on the left side of the box and goes to the right side. The range starts at the bottom of the box and goes to the top of the box. Domain and range. And so sometimes the minimum and the domain and range go together. Sometimes the max and mins do not. Okay? So the box is what's telling us what the playing field is, and then we get to play inside of it with the graph. So now let's look down here at this next question here. It's talking about the probability, table of values, probability, what are the chances, that's what probability kind of means, right? The chances that's kind of what you're looking for, the chances of something, for getting all 5s when you roll a number cube n times. So if I roll it once, what's the chances of getting a 5? 1 out of 6. Okay, what if I roll it twice? What's 1 out of 6 times 1 out of 6, which is 1 out of 36. If I roll it 3 times, what are the chances of getting a 5 3 times in a row? So 1 out of 6 times 1 out of 6 times 1 out of 6, and you get this right here. Well, do it again, times 1 out of 1 6 times 1 6, and so you see what's going on. So when we talk about P of n, is it says it increasing or decreasing. So are these values getting bigger or smaller? Okay, so if these values are getting smaller, how is that significant to our probability? Okay, how is that significant to your probability? So let's explain that idea. Okay, now this says the end behavior of this guy right here. So the idea is this: if we keep on going, okay, this is going to keep on doing the pattern it was doing, but will it ever cross over? Will it ever actually get, even though it may be getting, will it ever go negative? No. So this is very, very similar to section 1, number 7 of the homework, right? Where you had that little, and then you had your axis coming down here, kind of like that. So it's similar to this idea. Similar. Okay. But it's, not exactly that idea, but it's in that neighborhood. Okay. So maybe that'll be some good hints for you to get you started. So there's Module 1, Section 2 with homework suggestions on top of it. Okay, now we're going to go on to average rate of change in our next video. Thank you.